All right, off we go. So, hello all. My name is Mariusz, and I'm a red teamer back in ING. We are doing this like global real-world red team engagements, and therefore we have collected a bunch of tricks that were useful during our endeavors, and as well as since I'm especially inclined towards the malware because I used to analyze and dissect malware samples as well as write my own. Therefore, I am more interested into devising malware stuff. So I would like to share with you a little bit of tricks and tactics that we could use malware-wise towards increasing our chances during the red team operations that we'll be having. So what we'll be sharing today is a few tricks about the phishing, as well as how can we approach the initial access stage during the in the more highly secure environments, as well as a little more into the evasion ideas, because as we might imagine, the evasion is really important in order to survive the multiple stages of detection and sensing dodgy stuff. Therefore, we might want to cover some of the more recent ideas how to combat them. And as a disclaimer, of course, there are no fancy new tactics in this talk. We've got a bunch of stuff that we use and keep privately low profile so that we can operate still within our networks. But among the things that I can show to you today, we'll be covering a few ideas that are already quite known, but yet can be still weaponized and used during the engagement. So one of the tricks that we really like abusing is to use the legitimate third-party services, such as, for instance, LinkedIn, and they abuse them to smuggle the URLs so that the employees who are not that sensitive about conversating with the mind-like experts from all around the world are more inclined into opening actually this kind of stuff. So smuggling the malicious payloads within the attachments is no more a viable approach towards targeting companies, because the email scanning systems are so good at detecting dodgy stuff within the attachments. Therefore, we would consider to just sticking away from the attachments-based malware and sticking more into the URLs. And URLs have this like a little bit of a problem behind. They are like causing this a little bit of a problem for the security scanning and the proxies and systems, because there's hard to tell the intention of the landing page that the user is about to hit. So there's very hard logic to be implemented towards sensing whether the URL attached to the email is going to be dodgy or not. And among the other tricks that we might chain altogether within the email or the conversation that we'll be trying to develop are the things like the right-to-left override trick, which still works quite nice during the most recent times, even though that was like designed or devised like 10 or 20 years ago, so still keeps on giving. And also, we consider that these like a little bit of not so developed kind of phishing ideas for just firing a single email and forgetting about it and just waiting for the user to get infected are no longer so much successful anymore, because users are not so much inclined into clicking on the very first email that they have received from this particular sender. In order to better understand what we are dealing with while we are delivering the email message, we came to the effort to just actually send like hundreds of emails towards the Office 365 email scanning system, the Microsoft Defender for Office 365, and we've been trying to conclude what were the SMTP headers getting back to us when we trying to analyze and examine the results during our internal analysis efforts, and we came to the observation that there were like more than 20 SMTP thread rules and rules numbers that we could actually, with a great deal of certainty, establish that the rules are getting back to these particular observations within and related to the emails. So, for instance, having the sole existence of the A URL within the mail is going to trigger back on a single anti-spam or threat rule. So we could just imagine, but there are like a bunch of others that will be hitting back on our emails that we could be aware of. So I think that this is like a valuable idea to try to learn how our mails are getting scanned and what engrams are being extracted out from our emails. And then, before we actually deliver something, we could be applying this idea of linting our phishing emails before we actually fire them away. And by the linting, we mean to have this like couple of safe checks implemented within our scriptings. So, for instance, stuff like how many URL parameters are there in the URL that we are about to attach into the mail message. This is the concept that still matters because we have observed. Just let me get back to the previous slide. We have observed by going through all of these rules that there were some rules, there were like more rules being provided back to us when we provided the URL containing multiple get parameters, whereas while we kept it short, lean and mean, quite concise URL, it will get back with less amount of anti-spam rules in SMTP headers. Therefore, we concluded that we will be better off with keeping our URLs nice and shiny and tidy. And among the other tricks that we found is that there has to be HTML smuggling involved when we targeting Office 365 environments, because just simply pointing towards the file would obviously get that file being fetched by the automated sandboxing mechanism, and therefore it might get detonated and, of course, burned before we even reach out to the very first employee that we try to target. So, well, stating the obvious, we cannot have this kind of bad smells within our URLs, such as like directly pointing to the extension, because obviously the automated, and especially during in the machine learning times, automated models are going to be very sensitive about it. Therefore, we are applying this idea of linting our phishing mails before we actually fire them away, so that we won't be leaving this kind of smelly traces. And among the others, what we found is that, for instance, even such an idea of embedding images encoded within as the base 64 blobs within the HTML is going to impact the number of anti-spam rules being matched on our email. So we found that it's so much easier and it's so much safer to just point to the remotely hosted images while still risking the notion that the employee might not enable fetching remote resources. We are okay with that, as well as trying to maybe attach them to the email, just as the way as we are attaching the images within the signature. So the base 64 is a not so stable approach to go about designing HTMLs. And it might be a little bit hard to explain, but what we found during our trials and errors was that this like convoluted approach of 3 next hop servers targeting the Office 365 environments worked the best for us. So the first one will be having this like GoFish on the EC2 instance. Then there is going to be this like vanilla empty EC2 redirector that just pushes on behalf of Socket all the mails targeting the 557 TCP port, and then redirecting them away to the SMTP, which is a high reputational, well-trusted mail delivery system. And therefore, Office 365 will just sense back all the way to the very beginning on the received service examination. So it will sense that, okay, this is the SMT, and this is the Gmail that provided me that email, and Gmail is going to do the same about our vanilla EC2 instance, and it's not going to sense anything dodgy about it, because it's like the IP points back to the AWS and state, therefore, well, this kind of like, this might be well-trusted IP pool, so Gmail may be not so picky about it, and therefore we can we can deliver the emails to the Office 365. At least this is what we are speculating how this might work, because obviously this is like black box, therefore we cannot be sure. Also, what we observed is that after delivering like this 4 or 5 emails, the Defender is going to cool down on us, but then after like waiting a few hours, we'll be able to bring back on the same domain that we used to deliver these first emails. Now, with regards to the initial access, there are a few approaches that still work, and of course this is very, very highly environment as well as company dependent. Therefore, some of the tricks might work for your environment, whereas they won't work for our. So the gift that keeps on giving is the idea to phish to persist instead of phishing to access, and there was this very nicely put up the article coming from Matt Hand from SpectreOps, who just exactly described what we were thinking about for the past months, but we couldn't just put up in this elegant wording as he did. So. For instance, it's so much better, it's so much more reliable to just drop the DLL into a very specific sweet spot and have that DLL follow the proxying or the sideloading idea. So, for instance, we could very easily weaponize the sideloading against Teams, where we can just easily find that Teams is trying to load up the version DLL coming out from its Microsoft Teams directory within the local app data. Therefore, we can easily craft our own dodgy DLL and just persist from inside of the VB script or the VBA just easily, while still chaining the file write and exec steps. Yeah, so I wouldn't be so inclined into using the typical Windows script host kind of file vectors. Things like HTAs, JScripts, and VB scripts used to work for many years, but now when we have the era of very aggressively configured EDRs or EPP products, as well as proxies that even tries to extract the files and pass them to the automated detonation environments, so that we can just briefly mention about the Zscaler, who is having this like Apex sandbox bundled within it. So some of the proxy systems are very aggressive towards the files. Therefore, using that kind of all the vectors might not be reliable for our highly scrutinized environments. So, for instance, obviously transmitting the executable ones, such as MSI files, installation systems, as well as executables, just simply access. Well, however, this was convenient for a pretty long time. It's not much more reliable, as we can already know it. And there was this like very nice research coming from the George and Konstantinos back like maybe a year or 2 years ago, and they have described this very nice and hefty ideas for bypassing specific products, and we've been trying to we've been like heavily utilizing their outcomes. And what we can, for instance, say here, that some of the executable files will just slip through the product because of some unknown reasons, and this is exactly the same for the CrowdStrike, which is like known to be susceptible to having these CPL files, and the CPL file is just a simple DLL that exposes merely a single export. And also, there is this idea that we shouldn't be reliable on having plain DLLs. Having the malicious code within the DLL main is going to cause us a lot of problems because of the loader lock issues. Therefore, you might be better off finding primitives to run your dodgy code from the exported functionality instead of DLL main, because you'll be experiencing this undefined, unpredictable behaviors when you try to load your shellcode from inside of the DLL main, just because of this loader lock issues. Therefore, CPL is like a perfect idea to weaponize that kind of thinking about the DLLs. And also, the LNK files. The LNKs are such a decade-old threat. We cannot even think about, we cannot even imagine why is that threat still nowadays during the 2022, where Microsoft is so aggressive towards the macros and is so aggressive towards applying the mark of the web idea towards plenty other file formats. Why do they don't do the same thing about the LNKs? Like, we've been trying to come up with observation how much much common is for our employees to use to transmit LNK files, and we've seen, as it results from my talks with the Blue Team guys who have been trying to do this like threat hunting queries, that the LNKs could be quite easily blocked on the perimeter of the customers. Therefore, we might be just suggesting them to block that extension right away without losing any business use cases. So yeah. As well as HTML files. The HTML are not so anticipated as the malware vector, and still they can be delivered even inside of the attachment, and the HTML can easily contain the smuggling payload, therefore constituting all the rest of the infection chain just from inside of the simple email attachment. And what's funny about these email attachments is that we can apply this really old trick of just inputting this dandy Unicode byte into the file name, so that it will mangle with how the file name is being printed and represented back to the user, and therefore like trying to fool the more tech-savvy users into thinking that they are dealing with this like maybe a little bit more legitimate files such as fax1. Also, the VBA malware. Well, we consider that the VBA isn't going isn't going away any much soon because of how much is it used by the big players, such as hedge funds companies and the financial sector and the brokers. I even have my friend who is a lawyer, and he told to me that he's so used to working with VBA macros, even the lawyers, like colleague lawyers, are using that mechanism, that functionality, because they also have their own automated Excel spreadsheets that somebody has written like years ago that they are using inside of their companies. Therefore, it is still a viable approach targeting lesser aware users. That the yellow ribbon making them enable macros is not so scary after all, because we've used to work with this kind of files. Therefore, we can go about it. And there's also very nice podcast with Risky Business, where the CEO of CrowdStrike shared some of his insights with what he learned about from talking with Microsoft on this pushing back on macros decision, and I highly recommend to going back and listening to that podcast because it's very insightful. And also, we can think of like millions of ways we could actually weaponize VBA to bring us the code execution primitive. But according to our researchers, we have this like maybe 20 of different code patterns implemented within the VBA, and the three ones that are the most effective, that we found the most effective, were the simple file droppers, as well as the idea of James Forshaw for having deserialization from inside of the VBA code through the use of .NET interoperabilities interfaces, and XSL transfer mode, which applies the same logic. Also, there are some more or less anticipated file formats, such as just plain simple Word. We all are aware of the remote template trick within the Words, when we can just deliver the plain simple docs file without the macros, which will then be having this like a reference to the remotely hosted template. That template can have arbitrary example, meaning we don't need to follow this .tm kind of naming. Therefore, we could dechain the infection into two stages: first delivering the Macroless document, then having the macro-enabled payload delivered back to us during the remote resources fetching. And the same approach can be applied to the Excels by the use of mechanism called custom UI, which was designed to provide the customers the ability to customize the ribbon within the Office applications. And also PowerPoint. PowerPoint is also not so much anticipated format, and we found that I found that while working with my customers, that they haven't been experiencing macro-enabled PowerPoints. Therefore, they never considered that the PowerPoint might be the dangerous one. And also, the same observation applies to lesser known and more even exotic formats, but they don't share the same risk exposure because the Visio or the project is not so commonly pre-installed. There are this, like, additional applications, but still we need to be aware that while targeting critical infrastructure sectors, there are these architects and engineers who are used to work with CAD software, and CAD software typically has this backward compatibility with the Visio diagrams. Therefore, devising malware for Visio will get the power plant sector infected as well because of the software that the engineers and architects are using there. So we see that there are plenty more of dodgy extensions that we could be aware of, and therefore instruct our customers to protect themselves from. And to just support what we have already said, the VBA runtime engine is not only present within the Microsoft products, it is very, very ubiquitous among the architects and engineers, especially in CAD software, as well as other exotic ones such as ArcMap, GIS templates, and even oscilloscopes may have this support for VBA code, which is like kind of an interesting. Therefore, this increases the threat surface that there is actually behind the VBA story. And now a little bit backstory of the containerization idea. So so I assume that we are all aware of the fact that Microsoft tried to apply this quite a nicely sounding logic of blocking macros, where whenever they have this like taint flag that they are marked that they came from the internet, therefore these files cannot be trusted because they come from the untrusted source. So the macro is so the Office applications are deciding that, well, since that file source cannot be trusted, therefore I am not willing to run its code. Therefore, I'll make the decision for the employee instead, for the user instead, and just make him unable to even enable macros. So since we've been trying to find that kind of functionality applied to the Office 365, we've seen the Microsoft representatives telling that they have this very robust protection against the mark of the web. Well, I couldn't find the proper version of the Office 365 environment. Maybe you can just approach me after this talk and point me to the specific installation that has this feature enforced, but I couldn't just reproduce it. So we didn't yet found the exactly running and working idea for blocking Motevu enabled documents. But so in practice, it means that currently this doesn't really act as in the evasion. We have the evasion before even the security measurements was implemented. At least this is like my point of view. But it can act as the way of showing to the customers that there are much more extensions that should be considered as dangerous and therefore untrusted, such as ISOs or even IMGs, which are not so popular as the concept of ISO. And IMG is simply a synonym to the ISO. We can just simply rename the extension and we will have the same ISO inside of it. And we will be probably aware that the files within the container will not have the mark of the web file taint flag propagated. Therefore, even if the container itself is considered as coming from untrusted, the file inside of that container won't apply the same observation. And also, it was quite surprising to us that during the actual engagement, while we were constantly observing the print screens coming from back of our beacons, we just like observed these employees that were working with these PDF files that had like 10 and more files embedded inside of them. And that was this, and this was the Eureka idea for us, that hey, since the employees are using and do know, they are familiarized with this mechanism of having files embedded into the PDF, we are going to weaponize that, and we're going to reuse that idea for our endeavors. And it kind of worked. So we can also store files within the PDFs and have even them quite automatically popped in front of the user. And as you can see from the social engineering perspective, the prompt is already having this like secure defaults, and the enabling button is already highlighted. Therefore, just simply hitting enter or just simply forgetting about to read all of this boring stuff that is on the dialog is enough to get once infected. And now comes the beauty of HTML smuggling. So the idea of HTML smuggling is known for a couple of years, and we all learned, I guess that at least I have learned about this idea from the Outflank guys, who just shared this very cool research about the notion of having malware embedded within the HTML, which in turn contains this JavaScript. So there is this JavaScript automation that will unpack the file and drop it to the hard drive during the drive-by occasion. And it is just so this is just so surprising that this idea get our malicious files, regardless of their extension, regardless of their contents, easily just right into the victim's hard drive, because the proxies, as well as any other network positioned systems, have no way to differentiate whether the HTML or JavaScript is dodgy. And even if they were trying to just hook into this like dodgy words, we could apply heavy JavaScript obfuscations. Therefore, this is not the best idea for them to even try to sense dodginess within the JavaScript. And the only way to protect against it is to come up with clever and robust heaps rules on the downloads directory that the customers could apply. So for instance, running the CPL files from the downloads directory, this is an anomaly that we could model our detections around. Therefore, we could kill it by simply denying system to even think about running CPLs from the downloads ones. But also, this idea will only be effective if we anticipate, if we model the fact that our landing pages are going to be heavily scanned by the automated sandboxes, proxies, and even the prying eyes of blue team analysts. So we need to come up with this anti-headless timing delays, even the post-delivery and redirection, as well as we might be thinking about deploying decoy documents, so-called plausible deniability something. And then, as we can see all, there's like so much to protect against. Like during my attempt to collect every extensions that I would see quite nicely weaponized, I came up with this 73 extensions list. Maybe there's much more. These are at least the ones that I think that I would be able to weaponize. Therefore, they pose actual risk to the customers that we are protecting. So just simply trying to discuss with them the possibility of blocking these extensions if there is no business case for having them coming from the internet would be a nice mitigation strategy. Now let's get to the second part of this talk, the evasion in depth. So in order to maximize our chances for the successful breach, we need to be thinking about evasions at every step of the kill chain that we try to simulate. So every step of the kill chain comes with its unique challenges that we need to combat, and all of these challenges, when we are trying to emulate them inappropriately, we'll be leaving traces behind us, and therefore we should be trying to first test our samples within our environments, apply the threat hunting, as well as threat detection ideas ourselves within our lab environments, so that we can be in advance compared to our blue team colleagues and see what our Macroless samples are leaving behind, and try to address that traces and that leftovers ourselves. So starting with the delivery. We found that hosting our payloads within the within the good reputation servers, such as clouds, are the best way to get into the company, because of course this isn't that simple to just block entire Windows.net domain. Therefore, we might be abusing multiple different, for instance, Azure services to host our payloads, and there is no clear idea what to do about it when you think about companies' large-scale solutions to this problem. Therefore, I guess that it is beneficially to come over that threat, to try to model it and try to see if there is anything that we could do about it. So for instance, I know that some customers can simply block entire Amazon AWS.net because they are not using AWS resources, therefore at least minimizing the threat surface of that cloud. And also, Mr. Docs has this very cool project called Living of Trusted Sites, when he tries to collect every domain, every service, internet service that could be reused, repurposed for the file storage primitive. So, for instance, he just disclosed to us that we can simply upload the file to the as the attachments while working on an email within the Office 365 Outlook, and that file will then be immediately uploaded to the Azure cloud, and will get back to us with this nice outlooklive.net domain URL. So it will be quite trusted, but yet it comes with this very short validity of 10 minutes, something like that. So it's not that useful, but there are plenty of other ideas. Also, before we actually deliver the Office document, for instance, we should be applying multiple evasions on the file level as well. So, for instance, VBA purging, which works very good even now during the 2022 year, but yet there is this like, I would call it the backdoor. If you check out the official repository on the GitHub with the Office purge, there is this like left idea for having Yara signature being applicable on the file on the documents purged with that tool. Therefore, I would be advising to find another tool. There's a fork one that will get your files a little bit more stealthier as compared to Office purging one. And the Office document encryption is a terrific approach to just cut down on the detection to the very zero level when you just apply your custom password, or even the hard-coded default one, Velvet Sweatshop, will cut it, because as long as the victim provides his own password, the antiviruses and the EDR staff are unable to sense anything out of it. And also, when it comes to what we actually can do with the VBA, .NET 2.js is a still gift that keeps on giving. And even when it comes to Microsoft attack surface reduction rules, there's this rule called block Office applications from injecting into other processes. And we found that these ASR rules are ineffective against .NET 2.js, .NET loaded and deserialized assemblies. Also, the idea that we really like is to use the XSL transform node that we can see on the right-hand side, higher image. We are just providing the URL, or even we can provide the entire VBS XML, and that XSL rather, can contain the VB script or the J script, and that one will be launched, deserialized within the memory, therefore giving us this like low footprint, quite stealthy code execution primitive from inside of the VBA. And also, if we want to actually run something inside of the system, try to use the dechained execution approach. So instead of running your commands inside of the child processes, try to look for the primitives that will let you dechain the parent-child relationship. And also, don't evade MC from inside of the VBA. Just look for the other ways around it, like, for instance, using the more sophisticated VBA implementations. Instead of trying to patch the memory of the MC, this is not the way to go. This is not a scalable way to go. And another thing is that using the community malware, which CobbleStrike is now right now considered as well as the Metasploits one, Covenants one, they are used as these benchmarks for EDRs. The EDRs need to fine-tune their own detections towards these products, because the entire community expects that, for instance, the EDR XYZ will be sensing CobbleStrike within the memory, regardless of how well was it hidden. Therefore, the CobbleStrike will get us at some point probably detected. So, we can think about moving towards another C2 implants, such as, for instance, Mythic C2, which is open open source one, and it's really affordable to just try to work with it and come up with our custom implant for the Mythic and keep it in-house, just for case. And also, if you work with Sliver, just think about the idea that execute assembly, which is very convenient, follows the fork and run approach, which is something I'm gonna briefly cover about just in just about seconds. This is quite a loud idea for running our .NET. When we think about delivering the executables, also bear in mind that there is this prevalence and reputation analysis that our executable, regardless of how sophisticated that was only seen in the two devices worldwide. Therefore, it is considered as anomalous because it's so uncommon. So it will be detected and mitigated, contained, even before it has chance to shine and chance to apply all its sophisticated evasions and patches and so on. So strive for the DLL sideloading, hijacking, comp hijacking, whatever you want it, just don't use excess. Also, if you want to deliver the actual executable, you can think about heavily obfuscating your stuff. So there is this concept of obfuscators and protectors. I'm sure that we worked with UPXs and ConfuserX before. The only idea that I wanted to kind of enhance and release to my red team colleagues is to apply the entire daisy-chained load of full of the packers, so that we can have the result of one packer being fed to the another packer, and then even further complicate the stuff, and even maybe just apply some other stages to just signing files using the Scarecrow or the Mangle one, or even removing pair resources using pair reset, for instance, or even backdoor the files using the backdoor one. And also, when we are talking about responsibly delivering our cyber weapons, think about watermarking your implants. So just intentionally inject some signatures into your implants, so then when the blue team will get back to you in about half of a year later, and they will ask you, is that yours? You'll be comfortable with saying, yes, that is ours, because we extracted this AES JSON blob from inside of that executable, and we were able to apply our hard-coded our password that we have documented somewhere in our systems, and therefore we can extract the metadata out of the beacon or out of the malware ourselves. So ideas where to store, where to stuff that kind of watermarking are very simple. Just use the PE headers, maybe resources, maybe just stick up with the additional PE section, maybe even tamper with the DOS stub instead. Also, if you want to backdoor something because you like feeling that you really need to have this in form of a shellcode, but you still would like to leverage, to abuse the fact that there are like plenty of rich resources, icons, cursors, and so on, you could try to inject your payload into the legitimate library using quite a few ideas for writing and executing your shellcodes. And these two tools, the backdoorer one, watermarker one, are bundled within the Protect My Tooling package. So if you fancy using them, check out the GitHub repository that contains them already. And one of among the ideas that I would recommend would be to try to store your shellcode in the middle of the first code section, so that we don't introduce yet another one, as long as the shellcode is not overly long, and then try to hijack branching instruction from the original entry point and then point it towards the shellcode that you just injected, so that we don't even tamper with the address of entry point PE header structure. And even there is this like funny thing about just applying fake code signatures onto our implants. So for instance, here we are taking this idea and implementation and an exported certificate from Manifestation Matt Graeber from SpectreOps, and we are just taking his fake code certificate, we are applying it on the Apollo, and as we can see, Apollo before signing 30 detections, after signing with fake still stolen certificates, 8 less, and it just happens that a few products were susceptible to this kind of fooling around them. There is this also like quite a fresh idea of pumping and bloating our malware samples. I haven't played with that much with them myself yet, but we've heard that we can just inject the plenty of words, of English words to the very end of the executable, so that we can try to strive towards lowered effective entropy of the entire file. So that is the idea behind file pumping. And the file bloating, if we have the implant that will act as our persistent one, and we leave it on our hard drive, how about just increasing in size into something ridiculous, such as maybe 50 megs, and just leave it out there, so that maybe some AVs and EDRs will just look at this size and say that this is not something for me. Among the strategies that we can apply is to try to, of course, time delay the execution primitives that we have. When we, during our shellcode execution, there is this allocation, write, and execution steps. We could apply heavy delays among these subsequent steps, following the drip loader style of injecting stuff. It is quite effective towards the CrowdStrike even today, but just requires a little bit of love for refactoring it and playing with the source code. And then also we could apply some blending in to just find the remote process if we really want to go about remote injection, and to find about process that do has already preloaded CLR, WinHTTP, CredUI, so that we will be living inside of the quite legitimate process. But instead, I would advise against injecting into remote processes, because it is so complicated to do this right without leaving many traces behind. Even the sole idea of direct syscalls can be implemented inappropriately, therefore leaving traces and the detection primitives. So just try to stay in process, in line, instead of injecting. Forget about the injecting anything. We don't need to inject anymore. If we stay inside, if we operate inside of the DLL that was loaded to the Teams server, there is just no need for us to keep on injecting outside of the Teams, because we are already living in the legitimate process, right? So in order to push back on the DOM's Yara signatures, we could even try to unlink our malware PA modules from the PEP during sleep, just before that, so that there is this no CredUI, no WinHTTP, and I guess that this might even push back on some of the detection ideas coming from the EDRs as well. We can also apply the call stack spoofers approaches, as well as shellcode fluctuation, which tries to leave our shellcode within the read-write or not accessible memory pages, because we don't want to live, we don't want to reside, and we don't want to have our beacons left at the executable places, because as soon as the antivirus memory scanner sweeps comes in, we don't want to be scanned even in the first place, and the antiviruses, out of the performance reason, are going to skip on the executable pages, because they are not, skip not executable pages, because they don't fancy scanning every virtual memory allocations out there. So they should be trying this performance optimizations idea for scanning only the executable ones. So just keep your shellcode with, outside of the executable memory allocation when you don't operate. And also, if you fancy about patching AMSI and ETW, don't do it, because the corruption of AMSI.dll is being picked up by the defender lately, as well as CrowdStrike, according to my observations. Therefore, we will be better off pulling these hardware breakpoints, kind of a trick where we apply the idea of having four breakpoints that would then trigger during while entering the AMSI or ETW detection functions, such as AMSI scan buffer, and then from inside of that exception handler that will be triggered, because there's going to be a single step exception triggered as soon as the system enters the AMSI detection function. We'll be trying to just conveniently, swiftly just jump outside of that function while not touching any byte on the disk or in the memory, therefore not triggering these AMSI-related detections. Also, a cool trick, we can even convert Windows handles into process handles, and we can even apply the James Forshaw idea for turning a little bit of limited process handle permissions into the full access ones. So there is this very cool idea for having Explorer process handle without calling to the Open Process API. One of a bunker trick about McAfee is that we can try to map out every possible process that the antivirus or EDR has and try to see which ones are not covered with the self-defense kernel primitives, and find that there are these like GUI processes that the antivirus have running, and they won't be protected by the self-defense modules. Therefore, we can abuse them to just store our beacons inside of these processes, because they are going to be considered as trusted because because they are related to antivirus. So just simply find the FCNM process and inject just right inside of that one, and McAfee should at least remain speechless about our beacon operating in there. And also, funny thing is that your products might be storing these log files within the file system, and this is the case for the McAfee, which stores the quite verbose logging facility within the program data, and you can just simply review the outcomes, the contents of these log files, and just see for yourself that there are mentions about excluded processes. Therefore, as soon as we have this idea that some process is excluded from scanning, we can just abuse this #2 within the beacon and just put our task inside of that excluded from scanning process, therefore surviving attack from AVs. Also, command control wise, just don't follow the fork and round approach any longer. The execute assembly one is going to create this sacrificial process, is going to inject reflective DLL injection shellcode in there, it's going to reflectively load itself and then connect back to the beacon process over the named pipe. This is so loud, this is not so stealthy approach. We can be smarter about it and just follow the living inside of the process idea. Sorry about it. It means that I need to hurry up. All right. So just quickly summing up on this one, just use the bofnet from the CCOP, from SpectreOps. Also, be aware that there is this like private enhanced fork of that bofnet, which I am the humble contributor to, which gives us this execute assembly and job assembly primitives that work just like a breeze, so you can try to figure out where to find that one and use them during your operations to just live inside the beacons process. A few slides left. When you think about egress over high reputational services such as OneDrive, maybe GitHub, Slack, and if you think about connecting within the intranet instead of using SMB, which might be RPC firewalled, we could be better off using the primitives of LDAP, since when there is this domain joined system and there's another domain joined system, even in the highly separated networks such as Swift segment, they still need to connect back to the same domain controller, and we could use it to constitute a nice and hefty command and control channel. And also use the serverless redirectors. We've been piggybacking on the AWS Lambdas for a long time by now, and they come at real cheap, like $5 or so for months-long engagements, and they just constitute the sole idea of egressing to the more trusted domains. And when you think about exfiltrating stuff, when you just dump this very nice process memory, or maybe you even extracted entire Teams cache that Teams stores, you might be trying to compress it using a nice and handy zippy or zipper instead primitive, and then when you have this like 1 gig long of a zip file, you could just copy it to the OneDrive sync directory, wait a little, and then get back to the Office 365 using the stolen primary refresh token, and then just simply download the file out of the OneDrive web UI console. Because the OneDrive did the job for you for syncing back and exfiltrating the file, and you didn't have to even care for the employee to keep a little while longer in the job so that your file gets exfiltrated properly, because OneDrive does everything of that for you. Now as a summary, there are a little bit of more slides, but I just anticipated I won't be able to cover all of them, and all of the slides are accessible at my blog already. You can just you can go out and check out the slides for yourself, as well as try to use the Protect My Tooling tool, which I consider that could enhance our operations outcomes. And also, what I want to convey is that what I call the art of evasion is only as as successful as the number of tries we are applying. So we'll be failing like 100 of the times, but then we'll find eventually this one slide, when this one nice fancy bypass for the product that we are against to. So just don't forget, so just don't give up and keep on trying, and also be respectful to your blue team colleagues. Even if you breach the company, don't be braggy about it. Just try to work with them, deliver all of the TTPs, all of the samples. Just share with them with the cool stuff that you devised, because after all, we all want to progress, and we all want to adapt and keep on researching. And that would be all, I guess.